What's up guys and welcome back. Today I'm going to show you how to use the Java-based DynamoDB Mapper to perform load, save, query, and delete operations. We're also going to touch on some more advanced topics including entity versioning and custom object marshalling. So if you're new to Dynamo, DynamoDB Mapper allows you to represent your table in a familiar class-like structure in Java. It also makes your life a whole lot easier when interacting with the low-level DynamoDB APIs. So with that being said, let's jump right into it. So here I am on the DynamoDB console on the right here, and I have pre-created a transactions table and filled it with a little bit of data. So we see here that I have my partition key set to transaction ID and my sort key set to a date. So let's click on this and take a look at what's inside. Make this a little bigger. So here's the data that I pre-filled the table with. So we have 4 rows. We have a transaction ID, T1. We have a date here. We have an amount that corresponds to this transaction. Scrolling over a bit. We have a complex object, a customer. And within the customer field, we have a customer ID corresponding to the value and a customer name. With each transaction, we also have a type, so purchase or refund, as we see between these two transactions. And we also have a version associated with each row. Okay, so that's the format of our table. Now I also have an index on the date field, so a global secondary index. So if we go to indices, we can see that I have a date-index, and that is corresponding to the date field. Now, if you don't remember, GSIs or global secondary indices allow you to query on fields that are not your partition key. So we're going to be seeing a little bit of an example of this later. So I just want to show you what was going on under the hood before we get into it. So I have a Java project that's been set up here, and I'm going to keep these two side by side so we can kind of see our table and play with it while we're writing our code. So let's take a look at what we have here. So this is a Maven-based project. So I have 2 key dependencies. We have the AWS Java SDK for DynamoDB. That's version 1.11. And then I'm also using Lombok version 1.18 just because it makes my life a whole lot easier. So let's take a look a little bit more. So we have within our source, we have an environment class, environment variables. This contains my secret access key and my normal access key. Now for this, you need a IAM user that has DynamoDB permissions for all the APIs that we're using, which I'll include in the description section of this video. Now we also have a model section which corresponds to our customer, and the customer is the object that we were looking at in the Dynamo table. So associated with that, we have a customer ID and a customer name. I also have all these bunch of Lombok annotations here, as I said, just to make my life a little easier. We have a translator class, which I will explain a little bit later. So let's put that on hold for now. We also have my main class, which we'll be writing all of our code in, or the majority of our code in. And we also have a transaction class, and this is the bread and butter, or kind of the meat of the ORM. So all the interactions that we're doing with our DynamoDB table are going to be with reference to this class, so a transaction class. So we already see some kind of clues to that. So we have an annotation here saying DynamoDB table with table name is equal to transactions. And we can see here, my table name is actually called transaction. So obviously when you set up yours, you're going to want to set the table name to whatever your table name is. And then we can see we also have the corresponding attributes of my table all stored here as fields on the transaction object. So we have the transaction ID, the date, the amount, and the version, and the customer, which was the complex object that we saw before. So before we go into how to actually write the code to interact with the table, we need to add some special annotations onto this class that tells DynamoDB Mapper how to interact with your table, or the definition of your table. So if that makes sense, it'll make sense in a few moments here. So the first thing we need to do is tell DynamoDB that the transaction ID is our partition key. So over here, when we defined our table and we created it, we selected our transaction ID to be our partition key and our date to be our range key. So we need to tell the DynamoDB Mapper the same thing in Java language. So the way you do that is through annotations that are provided by the DynamoDB Mapper SDK. So we're going to be using those annotations now. So the first one is DynamoDB hash key. And this one tells DynamoDB Mapper that the value associated with this annotation is our partition key. So we also need to give it a attribute name, which is the column name that we want to store this field as. So I'm going to be using it one-to-one. So every kind of field name here, I'm going to be using it as the same name in the DynamoDB table. So we're going to say here attribute name is equal to transaction ID. Excuse me, a little bit of an error here. Okay. And we need to say the attribute name is equal to transaction ID. Okay, the same thing for date, except that it is slightly different. So it has two properties. It's actually a global secondary index, or a GSI, and it's also my range key. So I need to specify both of those things using annotations. So let's do the range key first. So DynamoDB range key. And we need to set the attribute name similar to what we saw above. Name. And we're going to set it to dates. Okay, that's good for the range key. Then we also need to tell DynamoDB that it is a GSI, and we need to map the corresponding index name that we created when we created our GSI on the console. So the way we do that is we say DynamoDB index hash key, and we say, again, attribute name is equal to dates. And then we need to provide it with a second field, which is global secondary index name. And that is, in my case, date-index. That's the name of the index that I created when I set up my table. So that's good for dates. Now for amount, this is just an attribute. So we can say DynamoDB Attribute in this case. And you can see here in the autocomplete, there's all sorts of values here, all specific to certain things that you try to do with your table. So for the amount, I'm just going to set it to amount. Nothing special going on here. And for version, so versioning is useful if you are in a multi-threaded or distributed system environment and you have multiple threads that can possibly be updating your rows at the same time. For a lot of you, this may not be necessary, but for my production applications, this is something I have to worry about. So we're going to be enforcing versioning on this example. And the way that we do that is we provide a special annotation called DynamoDB version attribute. And we say attribute name, and it's going to be the same thing, version. And if this didn't make sense, it'll make sense later when we do a little bit of the demos. Now on to the final one, and maybe the most interesting one, is the customer field. Now customer is kind of an interesting example. This is a complex object that has its own properties. So we need to do a little bit of extra work here in order for this to work. So we need to say, that it's a DynamoDB attribute. That should go without saying. And let's just fill that in. Attribute name is equal to customer. And then we also need to tell Dynamo how to convert from a string to a customer and a customer object to a string. We need to do it in both directions. And we're going to provide a custom class using a special annotation here. So that we're going to say DynamoDB TypeConverted. And we're going to say the converter is going to be the converter is the customer translator class. Okay, so this customer translator class is going to be responsible for converting into a string and out of a string when we're interacting with our Dynamo table. So let's go and fill out the code for this customer translator class. So we can see over here, let me make this a little bigger so we can all see. So we have a customer translator. It implements the DynamoDB TypeConverter, and we can see that it goes between a string and a customer and a string. It's an interface that requires you to override two methods, a convert, which takes in a customer and returns a string, and a unconvert, which takes in a string and returns a customer. So let's fill this out now. So I'm going to be using Jackson library to do my serialization and deserialization here. You can also use Google Guava, which I believe has a convert and unconvert library. But yeah, Jackson is what I'm most familiar with, so that's what I'm going to use. So let's say private static final object mapper. Object mapper is the entity in Jackson lingo that you use to convert and unconvert objects. Let's say mapper is new object mapper. That's all we need to do to set on it. And then, so now we're taking in a customer and we're returning a string. So let's get rid of this. And so we need a try catch here because the function we're going to use can throw an exception. So let's just fill this out. Try catch exception. JSON processing exception actually is the one that we need to worry about. And if this is thrown, then we just throw a runtime exception. Oops, new runtime exception. Runtime exception E. So what we were trying to do here is convert a customer to a string. So we're going to say return mapper.writeValue as string and customer. It's literally as simple as that. So it's going to take this customer object and return a version of it in string format, similar to what we were seeing in our table here, in this kind of notation over here. And similar, we want to do the same thing to convert a string into a customer. This is going to be used on the Dynamo side. Once it's retrieved the string from your table, it needs to know how to convert it into a Java class. So let's fill that out now. It's going to look very similar. So try, and we're going to say catch JSON processing exception as well. And then we're going to throw a new runtime as well. Okay, and then we're going to do the opposite here. So we're going to say return mapper, instead of write value, we're going to read value. Read value, since this is 1. And we're going to say the value that we're reading is S, since that's what we're passing in. And the class that it's going to convert it to is the customer class. Okay, so that looks good. Actually, so this can throw multiple exceptions. So let's just say exception E here, and then we'll rethrow whatever as a runtime exception there. That makes it a lot easier. Okay, so that's all we need to worry about in terms of our marshalling and unmarshalling of the customer class. So let's actually get into the fun part and actually write the code to interact with this table. So let's close this stuff. Let's close this stuff. By the way, I'm going to make all this code available, so don't worry about taking screenshots or copying it down or whatever. Close that. Close that. Keep in mind here for the customer class, the noargs constructor or a default constructor is required here. If you don't do this, you're going to have an error. So make sure that you do that. Let's go to our demo class now. And this is going to be our main method where we actually do the fun stuff. So let's make this a little bit bigger, expand this a little bit in this direction. Okay, so the first thing we need to do is create a credentials object, and this credentials object kind of gives us access to the role or the user that we're going to be using to interact with our table. So let's do that now. So we're going to say AWS credentials provider, and we're going to say that's creds variable is equal to new AWS static credentials provider. And we need to pass into this object a basic AWS credentials object. And into this object, we need to pass in our access key and our secret key. So I have that stored in a separate class here, so no one can see it. So the first thing is the access key, and the second one is the secret key. And okay, that looks good. So now we have a credentials object. Now we need to create a DynamoDB client where we specify our region and everything like that. So let's say Amazon DynamoDB DB client is equal to Amazon DynamoDB client builder. See if I can find it. There we go. We're going to say the standard version, and we're going to pass in some stuff, credentials, creds, which is what I just created, and also specify our region. I operate in US East 1 since I'm in North America, and that looks pretty good, and we're just going to build it out. Okay, so now we want to actually create an instance of our DynamoDB Mapper, finally. So DynamoDB Mapper is equal to, Mapper is equal to new DynamoDB Mapper, and now we just pass in the client. And now we're good. So now we can start actually writing the code. So the first thing we're going to do is we're going to try to read off of this table. So we're going to do some load operations. So I'm just going to call load over here. And this probably needs to be static. Static, you can do this all at once while I'm here. These are the operations that we're going to be writing in a little bit here. But the first one is load because it's the most simple, right? So let's just fill this out here. So there's a couple of ways to use load. And if you look at the class definition, there's multiple overloaded methods that you can kind of play with. So the first one is just what I call a basic load. So basic load. So the way that you use this mapper is that you need to create an instance. So I'm going to say transaction T is equal to a new transaction. Now, if I'm looking for T1, that's the key or the partition key, transaction ID T1, I need to set the field transaction ID on this object to T1. So T.set transaction ID T1, since this is the one I'm looking for. Now, if you're not using a range key, this is all you need to do. You just create this object, then you call the method I'm about to write, and then you can get your object back. However, since I am using a range key in this example, if you're not using a range key, then don't listen to this. But since I am using a range key, I also need to specify the range key value or the date value. Now, keep in mind when you're using a range key, the combination of the partition key and the sort key must be unique. So the transaction ID and the date, the combination of those fields must be unique. So if I just pass in T1 here, DynamoDB won't know which record to give me back, right? It won't know to give me this record that has the date March 1st or this record, March 2nd. We're going to see a way to grab both of these records back in a little bit. That's called a query. But for a load, it's a single lookup on one item. So we need to specify the range key value over here, so March 1st. So I'm going to say t.setDate is equal to 2020-0301, which is this first value here. Okay, so that is pretty much all we need to do a basic load. So let's actually just store this in a result. So transaction result is equal to mapper.load, and we just pass in the object now. So that's pretty much it. So if we just do system out print line here, print line result, and since I added the toString annotation on our transaction object, right here, we got the toString annotation, this will come out pretty printed. So let's actually run this now. Run. Oh boy. Okay, that looks good. Give this a second here. It's the first time I ran this, so it may take a little bit longer than normal. We should see the row returned back to us, assuming I didn't screw anything up. Yeah, so there it is. So transaction T1, amount 50, customer ID C1, name AWS simplified. That all looks good. So that's how you do a basic load. It's just a quick lookup on a single item, okay? Okay, so that looks good for loads. Let's move on to saves now. So we're gonna go up here and say save mapper, comment out the load stuff. Let's go and fill this out. So let's start out now with just a basic save, or what I call a basic save. So the way we do this is we need to create an entity similar to how we did it with load. So we need to say transaction T is equal to new transaction, T.set transaction ID, let's say T4, since we already have everything up to T3. So T.set dates, and we're going to say 2020-03-28, and we're going to say T.set type. This will be of type purchase. Let's scroll down a little bit. And let's set the amount on this guy, and it's an integer, let's say 999. And now we can save this complex customer object. And since I was smart before, I added the builder annotation, import that. We can add some customer properties using the builder method. So we're going to say customer ID, and we're going to say C2 and customer name. And let's say Jane Doe. And we're going to say afterwards .built. So that should give us a customer with the ID C2 that we're passing into this object. And once you populate the object, it's pretty simple. You just call mapper.save with T on there. Okay, so that looks good. So hopefully once this is done, if this runs correctly, we should see a T4 here. And give this a moment here to run. Okay, and click on Start Search, and now we have T4 with the new value associated with it. Okay, that's perfect. So let's assume for a second I made a mistake. Okay, so assume, oops, I set this to 999. It should have been 55. This was the value that I meant to update. Now this won't work, and I'll prove it to you by running it, and then I'll explain to you why it won't work. Okay, so we see that we got an exception here. So what does this exception mean? So conditional check failed exception. And if I can scroll over, the conditional request failed. And so what this means is that since we're using the DynamoDB attribute property, you actually need to perform a get or a load operation, modify the properties of the object, and then save it back into the database. And the reason this is to prevent multiple threads in a distributed system environment from interacting with the same row in parallel and writing over one another. So every time that you need to update a row that has a version that's associated with it, you first need to retrieve the row, perform your update, save it back, and then DynamoDB will auto increment the version number. So if we see here on T4, we can see that the version number is version 1. Now let's try to modify this. So I'm going to actually we can leave it as it is. I changed this to 55, but before I save it, let's actually retrieve what's there first, save it as 55, set it as 55, and then attempt to save it back to the database. So let's copy this out. And let's say, actually, I'm going to need these two properties here in order to perform the load. So let's say transaction result is equal to mapper.load t. So this will retrieve the row that has t4 associated with it. I also need the date. Don't forget that. And then we're going to set the amount, let's say, I don't know, 5 or 55 is what I said, right? So 55. And then let's call save, mapper.save, and then saving the result now. So what I retrieved back, I modified it, and now I'm saving it back to the database. So if this works, we should see this change to 55 for the amount, and the version gets incremented to 2. So let's save that. So okay, so version or amount 55, and version got changed to 2. So that worked perfectly. So that's something you need to be aware of if you're using the attribute feature of Dynamo, that having that feature means that you need to get before you modify and save. And there's also another way of saving that I wanted to quickly go over. It's called batch saving. So it's the third method, so batch saving. And it's pretty simple. You just do mapper.batch save. And you could pass in a bunch of things here. So it's variable arguments, so you can pass in as many as you want, or a list. Keep in mind that if you're using this approach, it does not respect the attributes properties. So even if multiple threads are modifying the same record, you can overwrite the work of another thread and not get an exception back. It'll just kind of brute force overwrite whatever is there in the database. So keep in mind, if you're using batch save, it doesn't respect the same rules of the DynamoDB attribute feature. Okay, so that covers it for save. Let's move on to how to query now. So query mapper. And we're going to do two different types of queries. The first query is just going to be a pretty basic query. And then the second one is going to be involving a global secondary index. So let's map that out here. So normal query. So we're going to query for everything with T1, with the transaction ID T1. Okay, so there's 2 rows here. So our expectation is that we're going to get back 2 rows from our query. So let's say transaction T is equal to new transaction, similar to what we did before. T.set transaction ID T1. Okay, now here comes the interesting bit. So DynamoDB query expression is what we need to use. And we need to say it's generic type of transaction. We're going to assign it to a query expression variable. We're going to say new DynamoDB query expression. And don't forget to add in the transaction for the generic. For some reason, it doesn't like that if you leave it as default. And then we're going to say with hash key values. And we need to pass in T1, or T rather. T. There we go. And then I'm going to say with limit 10. So with limit here is actually optional. The default behavior, if you don't pass this value in, is that Dynamo will attempt to retrieve up to 4 megabytes worth of data. And if it's more, then it'll just kind of cut you off. However, if you specify a number here, it'll attempt to retrieve that number of rows. So 10 rows with the key T1 in this case. Okay. So the result here should be a list of 2 rows. So T1 with 2 different dates, 01 and 02. So let's actually perform the query now by saying list transaction. And we're going to say import list. That would be great. Result mapper.query. We need to pass in the class type. So transaction.class and the query expression. Ooh, what just happened there? There we go. And let's just do some basic print lines here. So I have some shortcuts, make this easier. So result, let's get the first one, .get 0, and get the first, or the second one at index 1. And so let's run this now. So we should get 2 rows back, one with March 1st and March 2nd as the date. Yeah, so there we go, March 1st and March 2nd. So that worked perfectly. Let's comment this stuff out now. We're going to do this with the GSI now. So let's say Query 2 is query with global secondary index, or GSI. Now, if you don't know what a GSI is, it basically makes it such that you can query by key on different values that are not your original partition key. So recall that I created my date as an index, as I showed you in the beginning of the video. My date field is a global secondary index. So what that means is that any value here I can query and grab it by lookup, by ID. So I can say, give me all the values that have March 1st here. So that's exactly what we're going to do. So let's say now transaction T, similar to what we did before. Oops, can't spell. Transaction T, new transaction. I rely too much on autocomplete sometimes. And let's say t.setDate. See, now we don't need to set the transaction ID. We only need to set the date because that is the key that Dynamo is going to be using for the lookup. And that'll make sense in a second here. So we're looking for over here 2020-03-01. So 2020-03-01. And then it's pretty much just business as usual. So same thing, DynamoDB query expression transaction, query expression equal to new DynamoDB query expression. Transaction. There's a couple different fields here that we need to be aware of. So same thing, we're going to do hash key values, and we're going to say T. Now the special thing here to kind of indicate to Dynamo that we want to use the GSI as the property of the query is we need to say with index name. And that with index name needs to be the index, the name of the index of the GSI that you created. So the name of the index that you created when you set up your table. So mine is called date-index, so that's what mine is going to be called. And then you have to say with consistent read is equal to false. Now there's two types of reads. There's strongly consistent and eventually consistent. So consistent read false means that you're using eventually consistent. So why do you need this? You have to use false here. You actually don't, you can't set it to true. You only can use eventual consistency on a GSI query. And this is due to the nature of how DynamoDB works, or GSIs work to be specific. So when you have a GSI, it is a projection. It is a duplicate table that is rotated on its axis. So the data that is written to the primary table, your main table, eventually gets propagated into your secondary table where your GSI is located. So there's an inherent delay there. So there's a possibility of when you query on your GSI, you will get stale data. And this is what this kind of field here is forcing you to recognize, the possibility of stale data. So setting it to false is absolutely mandatory. If you don't do that, you're going to get an error back from Dynamo, and we don't want that. And then again, we're just going to say with limit and 10. Obviously, we don't have more than 10 here, so it doesn't really matter. And then we're going to do the same thing. I'm just going to copy and paste this stuff over here and just comment out this business because I like good formatting. I'm going to fix this. And now we should get two rows back, both with these two dates, 2020-03-01. So T1 and T2, if this worked correctly. So let's test and see if it did. Okay, run T1 and T2, both with the same dates. So that kind of corresponds to how GSI queries work and gives you a good working example of how to perform them. Now let's move on to delete. So let's move back up here, minimize that. Query is done. Now we want, what's going on? There we go. Delete, mapper. And now we're going to delete record T4 over here. So it's going to follow the same principles, and there's two different types. There's a single delete and a multi or batch delete. So let's do single delete first. So single delete. And we're going to say transaction T is equal to new transaction, like we always do. We're going to say c.set transaction ID, and that's going to be T4. That's the one we want to get rid of. And we also need to specify the range key, or aka the sort key. And in this case, it's 2020-03-28. So 2020-03-28. And the same property applies as the update. We can't just run this as is. First, we need to query, acquire the row, and then perform the delete. If you try to do just a delete on this entity here, you're going to get that same conditional check failed exception that we saw previously. If you're not using attributes, then you can just go ahead and do this. But if you are, then you need to do a load followed by a delete. So let's say transaction result is equal to mapper.load, and we're going to say T because that's the one we're looking for. And then we're going to say mapper.delete whatever is there. So mapper.delete results. And now let's run this, and after I refresh, T4 should be gone. Assuming this worked. There we go. And T4 is gone. Fantastic. So that's the simple way. There's also another way, which is a multi-delete or batch. And it works the same way works the same way the save works. So it's just mapper.batch delete. And you can pass in multiple records here. Same kind of deal. Keep in mind though, same rule that this does not honor the rules of attribute versioning. So you don't need to get before you delete. But it also means that if a different thread is updating, you may actually delete the row that another thread made some modifications to. So keep that in mind when you are working with these batch deletes. They do have some limitations to them. So hopefully you liked this video. I have many more on DynamoDB that I'll put in the description section below. And please don't forget to like and subscribe so you don't miss out on next week's video. Thanks so much, folks, and I'll see you next time.